Meta's Muse Glimmer is a 30 billion parameter dense reasoning model designed specifically for consumer hardware. In this video, we're going to cover three things. First, how does it perform as a software engineering tool? Today, we have qualitative results for Glimmer on 77 private benchmark tasks. We're comparing this against the 27 billion parameter Qwen, which is currently the best-in-class model. Spoiler alert, Qwen wins. Secondly, we're going to cover how to run it. What hardware do you need? How should you configure it? What kind of performance do you expect to get? And third, what makes a Glimmer unique and interesting? It has some quirks with the reasoning and with its output. Finally, I've put the assets, graphs, and prompts to get started with Muse on optimal settings in my GitHub, something that you can just copy paste into Claude to get running. And the link is in the description below for that. The three graphs are going to show us everything that we need to know about the performance of Glimmer. This is token efficiency, and so where we want our dots to be is in the upper left, indicating that we got a high percentage of the test suite correct, and we did it with very few tokens used. And we can see the cluster of two models up here, the 27B Fable Fusion 711, as well as the 27B Base Qwen, both doing very well up here with high scores and few tokens used. Glimmer, the 30B, is kind of wedged in there between the 27 dense and the 35B MOE model from Qwen. Let's take a look at the runtime. So this is the total suite runtime. It took Muse almost 7 hours to get through this suite of tasks, and Qwen 27B completed the same set in 3.8 hours. This orange section indicates when the model timed out running something in the foreground that prevented it from actually performing work. Muse Glimmer did that at a far higher rate than both the 27B and the 35B Qwen. What about the verbosity? So each of these x-axis points is a different task. It's much more verbose. So Glimmer takes a lot more tokens to do the same amount of work that Qwen does. What kind of tasks do we have in the benchmark suite? It's got tasks modifying memcached, which is a popular open source tool. There's very large C files. It's challenging to edit a 2,000 line C file when you're a small model like this. It's got tasks doing particle simulations with physics effects like gravity and particle charge. It's writing web apps. It's scripting against a comfy UI endpoint, creating images using stable diffusion. And each of these tasks is in a skill ladder. So the tasks get progressively more difficult until they overcome the capabilities of these 30 billion parameter class models. These are all discriminating skill ladders rather. So they all have a task that's too hard. Now that we've looked at the benchmark, how do you actually run this model? And what should you expect in terms of tokens per second? The short answer is you need a 24 gigabyte RAM graphics card or an Apple Silicon Mac with 32 gigs of RAM. I'm going to go out on a limb and say that these are fairly common compared to the more exotic architectures that you can run a local LLM on. Let's also talk very quickly about what the most common configuration options are that you should use with Llama Server. Chances are the app that you're using to run a local LLM is either Llama Server or using it under the hood, so I'm going to focus on that. As far as quantization goes, download the Q4 quant of the model. And on NVIDIA, make sure you don't allow your config to spill into RAM. You want the entire model and your token cache fitting onto the graphics card, or you're going to get severely degraded performance. It's not a little bit worse, it drops off a cliff.
So on pre-fill, I'm getting about 13 tokens all the way down to 4.5.
Another thing that I think gets overlooked a lot is the KV cache quant. If you set this to Q4, you just get more cache and you don't get degraded performance. The data in this chart is from a different model, but the end result is that you don't lose performance on these kinds of tasks by quantizing the KB cache. In addition, I have some evidence that, and this is on a 9 billion parameter model, but it gets faster when you quantize less, but it doesn't get dumber. If you follow these guidelines, you're going to have a great time. This model runs fantastically on a 24 gig graphics card. 70 tokens per second out and 1,000 tokens per second in on an NVIDIA graphics card. That's on a 3090. The 4090 just is even way faster than that. And the 70 output tokens, this is like 5 times faster than you can read. It's plenty good. What's unique about Glimmer? Mark's giving it away for free, so you know there's got to be a catch. Yeah, really, to put it in words, Glimmer drops articles everywhere. Let's write edit. let's check output folder. It looks a little bit like GrugBrain Developer. It tends to do this less in the output to the user, but you will find code comments written with Glimmer that reflect this kind of very, very terse style. One more illustrative thing that's a little bit strange about how it thinks is you'll see this when you're working with Glimmer. In this particular conversation above, it did a bunch of work. It had 41 turns, as we can see here. And then it ends with a thinking block that says run it. And it just executes the command. And it doesn't say, here's what I did, here's what was successful, here are the tool calls. It's just like drops the mic. I haven't seen any other model do that. On the right-hand side, here's how often the model says nothing at the end of the task or the conversation. This is out of 77, by the way. So this is like 80% of the time. It just quits. And then the 27B fine-tune on Fable. So Fable Fusion 711 does that more frequently, relatively more frequently. And then base Qwen just doesn't really have that behavior. And then how much it thinks, this is the median thinking tokens over here. So if you wanted to anthropomorphize this a little bit, Glimmer thinks a lot and then doesn't talk back very much. Okay, let's take a look in detail at one task. The agent is dumped into a Docker container that already has Comfy UI running. The agent needs to examine its current running environment and use an API to execute the command. It's relatively challenging, and the 30B class agents fail at this frequently. But we're going to see a few different quirks all at once of how Glimmer operates. So the first thing to notice is that it starts its thinking block by restating the entire input prompt. Now, I think this is counterproductive. I think this is just a bad behavior, and I imagine that they'll try to fix this with a future release. I don't think this makes any sense for the model to be echoing what the user put in. Here is an example of it dropping a small word in the middle. I think this is an infinitive or an article or something, but it says we need to find file named rescale, possibly in opt-comfy. Let's bash ls. It's just dropping all these little words that are glue in English that don't really change the meaning, but are typically there for grammatical correctness. First, explore opt comfy UI. I think it's funny. At first I thought it was endearing and kind of fun, but now I just think it's not a pleasant behavior of the model. Look at this. We need run it. I don't know. It just makes me feel like I'm working with a caveman. I'm not amped about it. That's not to say that the model is doing the wrong thing. It goes off and it's exploring the code base and it's exploring what's going on the machine. And then I'm going to skip to the end where it's kind of figured out what it needs to do. And it kicks off a request to the server that's running within its container. It successfully figured out the format that it needed and the JSON arguments and everything. And it generated an image through Comfy UI. Good. That's a success. And here's where it shoots itself in the foot. Wait for completion, and it writes this while loop, okay? And it has a time.sleep in there, and the error is that this if statement is just never true, so it never breaks out of its while loop. A more intelligent agent, maybe like Opus or something, would set a limit on the amount of time that this would run for, waiting for verification, and instead Glimmer stopped making progress on this benchmark task. In summary, I think this is a good model. I think it's an interesting release, especially coming from Meta, given that they started a lot of the open source and open weights movement with, or popularizing it at least with the early Llama releases in 2023. I don't recommend this over the Qwen 27B. I think Qwen 27B base remains the strongest reasoning model that you can run on hardware at home without spending a lot of money. Thanks for taking a look at this. I'll see you in the next one.